This is video 9.1.1, and the goal of this video is to be able to graph and find the standard rule for an ellipse. So you've already talked about the definition of ellipse in class, but just to recall, it's all points in a plane who the sum of the distances from two fixed points is constant. So remember, it's adding from one fixed to the point and then to the other fixed point. So adding these two segments together will equal the same distance as any other point. So if I added those two distances, I would actually get the same. Or if I came here, I'd add these two distances, and it would be equal to all the other distances added. So with that, our equation for an ellipse will give us some key information again about the graph and about the picture that we're going to draw. So if we have the standard equation of an ellipse that is centered at the origin. So now we have an ellipse that's at the origin. That's where the center of the graph is, as you can see in these two. And we're going to write it. Notice that it's always going to equal 1. Now, notice again the difference is where A is and B is. And the reason we do that is because A is going to be representing the longer length, the major axis in this case. Because the ellipse is not, if the two axes are equal, then that's now a circle. It's no longer an ellipse the minute they're equal. So we're talking about A in this case would be this longer side, and B would be the shorter distance in the first ellipse. The other ellipse, notice A is the longer one. It's the vertical axis, and B is the horizontal axis. So it is major and minor axes, and so the reason that's important is mostly because of how we find the foci. The foci are really key points to using ellipses for applications. So while the foci are not essential for graphing, they are essential for applying the graphs and the use of ellipses in the real world, and so it's important we know how to find them. So that really key relationship down at the bottom will work no matter if the ellipse is at the center of the graph, at the origin, or if it's somewhere out in the middle of the coordinate plane. And the rule is always to subtract the two axes. So the major axis squared minus the minor axis squared. So that's just an overview. So otherwise it's very similar to graphing a circle, but it's going to have two separate sort of radius distances that you're going to use, and then you're going to just sketch them together with an arc between the different 4 key points that you'll find outside the circle. So you'll find these 4 key points using the axes, so the A and the B values, and then you will sketch in that curve. So let's take a look at an example and make sense of this. So we're going to graph and look at the foci, but what you should notice right away is that this is not written in standard form. So the standard form was x squared over something plus y squared over something equals 1. So remember that key 1 that we saw over here? We have to have this to be 1. So it doesn't even matter that there's a number in front of x and y. What matters is that 36 is not 1. So we manipulate it and we make it 1 by dividing everything by 36 to make the right-hand side 1. But I have to do everything on the left as well. So I'm going to divide everything on the left by 36 as well to get an equivalent equation. Now I have the 1, and I have everything else on the left-hand side. Now, in order to get, and remember the reason I added 1, I divided, was so that I wouldn't actually add a constant onto the other side. I want just the x squared and the y squared. I don't want to add anything on. So I divided by 36. Now I'm going to simplify the fractions because x squared, 9x squared over 36 is really just x squared over 4. And 4y squared over 36 is just y squared over 9 equals 1. So now I have it written in standard form. And I see my major axis is in the y direction because 9 is larger. But I can write 9 as 3 squared. And remember, it's just like with the circle, it's the value squared. So I have to figure out what that is squared. My minor axis is 2 because 2 squared is 4. So, and it's centered at the origin. So now I'm going to sketch my graph using this key information. So I have a minor axis along the x of 2. So I'm going to go 2 in both directions. And then my major axis is 3, and that's in the direction of y because it's under the y value. And now I have a nice sketch of my ellipse. Now the other thing that I'm being asked to find is the foci. And remember that is the difference between the major axis squared minus the minor axis squared will equal c squared, the focus squared. So I'm going to subtract the two. And so it's really 9 minus 4. So those are nice points to know. 9 minus 4, 5, but that's equal to c squared. So c is not 5. C is actually 2.23. So that's actually the value of c. Now just like a and b, it's actually a distance from the center. So we go from the center 2.23 along the major axis. Okay, so that focus is always on the larger of the axes. So it's going to be in the vertical axis in this case. So I'm going to go up 2.23 in both directions approximately. And on a test, you'll either off to the side represent the foci by telling me that it's at 0, 2.23 and at 0, negative 2.23. And you'll just represent those off to the side to show me you understand where the focus are, and you'll put them on the graph. F2, F1. So those are key points. Remember, those are mostly for applications, but we're going to get in the habit of graphing them and finding them every time we graph an ellipse. Let's take a look at the next question. Now we're being asked to write the rule for this ellipse. So we remember the rules: x squared over something squared plus y squared over something squared equals 1. So the key points are what are these somethings? And remember, those represent the axes. The value under x squared is the horizontal axis. It might be major or minor. In our case, it is a length of 2. So it is going to be 2 squared. And then the value under y is going to be the vertical axis. And we see that it is 4. So it's going to be 4 squared. So the standard form of my equation is y squared over 16 and x squared over 4. Or you can leave it in squared form. Both of these, this is correct and this is just fine. And you're done. It's that simple. So now what happens now when we shift the graph? Well, just like when we shift parabolas or when we shifted circles, it simply shifts the center, but really everything else kind of stays the same. The process stays the same. You're still going to find the major axis and the minor axis, but where you start from is going to be different. So this is going to go in your notes packet that you created in class. So when we're talking about shifting an ellipse, the first key thing is that the center is now at h, k. Okay? Now let's say my major axis was the horizontal axis. Then my focus, remember, points would be on that axis. So notice they're all along this horizontal line. So that means everything is going to have a k value because it didn't go up or down from that. So all my foci and my vertex points along the major axis will be k at k for the y value. But the vertex will be h plus a. And the reason for that, remember, is it's at h right now, but then we're going to go across in this direction a distance of a, which represents the major axis sort of radius, the distance to that vertex. And then, of course, going the other direction, same idea, but the other vertex is h minus a. We're going to go a to the left instead. The focus is very similar, but now remember the focus is always a distance of c away from the center. So now the focus will be at h minus c and h plus c. So all those values are still the same. You're simply going to walk to the left c and walk to the right c in order to get to your focus points. And of course the vertical axis is the minor axis in this case. And the way we're going to find these key vertex points on the minor axis is the same idea, but notice which value stays the same now. Of course, h will stay the same because we're not going left or right, we're just going up and down. And we're going to go down b and up b. So on the bottom point, it's going to be k minus b, and on the top point, it's going to be h comma k plus b. So again, it's the same idea. You're finding a distance of b, up and down. to get to your minor axis major points, those most important points. So those are the notes that you should add to your packet for class. And we're going to do one example where there is a shift and kind of talk about how to graph that and just to make sure we understand it a little bit better. So we're graphing the following problem. Notice it's already written in standard form. The standard form, I guess I didn't write that down, but here's the standard form that you'll need. Okay, it is x minus h squared over a squared plus y minus k squared over b squared equals 1. So notice the only thing that's changed is the h and k now get incorporated into the perfect square there. And again, h and k are your center, just like in circles, just like in parabolas, it's your key vertex. So all that's consistent, and then a and b are the same idea as we saw in the previous examples. So that's the standard form of the ellipse. So let's take a look at this graph of this ellipse. So our first thing is, not even listed here, but we do want to find the center of the graph, the center of the ellipse. The center of the ellipse is always the h comma k. In our case, h and k appear there, so it looks like h is -2 and k is 1. So we're going to go to -2, 1 and graph that point. So that's our center. The next thing we're going to do is find, like it's listed here, the vertices, which are the endpoints of the major axis, and we're also going to find the endpoints of the minor axis. So let's find the vertices. The vertices, that's the major axis. So we're looking at the major axis. In our case, it's going to be in the x direction because 9 is bigger than 4. But first we have to think of this as something squared. We have to change this to 3 squared because in standard form it's a squared and b squared. And we'll think of 4 as 2 squared. So my major axis is going to be a length of 3 in both directions. So I'm going to go over 3 from both directions from my center. So my vertices are at -5, 1, and 1, 1. Now I'm also going to find the endpoints of my minor axis in the exact same manner. So the endpoints are only 2 in both directions, so we're going to go 2 up and 2 down because they were underneath the y value. And then we'll just quickly list the points. So we're at -2, 3 and -2, -1. Those are my endpoints. Last but not least, I need to find the focus points. Okay, I want to remember they're always on the major axis. So our major axis is this horizontal axis here. And the last thing I need to remember is that c squared, which represents the distance to the focus squared, will always equal a squared minus b squared. So in our case, a squared was 9, b squared was 4, and we get 5. Because remember, a squared minus b squared, 9 minus 4. But that's equal to c squared. I need just c. So I'm going to square root that and get 2.23. That's the value for c. It's a distance. So I'm going to go 2.23 in both directions from the center of the graph, 2.23 in this direction, and 2.23 in the other. And that's going to help me find my 2 focus points. F1, we'll call it. It looks like from -2, I went 2.23 to the right, and I ended up at positive 0.23. But it was still up 1. So 0.23, 1. The other focus point is at backwards 2.23, so now I'm going to subtract 2.23 from -2, because I'm going into the negatives further, and I'm going to get -4.23. That is the value of the second focus, F2. So I have all my key points graphed. Now labeled, excuse me. Now I'm going to just connect my ellipse, and I'm done with this problem. So there is your first official ellipse with all the transformations of the shifting and the change in axes. So your job on your checkpoints is to give this your best shot. Remember, your goal is to try everything and be sure to answer the questions on the Google form. the first problem, you're simply going to write the equation in standard form and graph it, so you'll make a nice sketch of it. The second question, just like we did the previous example, your goal is to graph the second one and be prepared to answer questions about the foci and the vertices and endpoints of the minor axis. So bring your questions into class, but be sure to try the checkpoint problems and answer the questions on the Google form.